So as I said in the previous video, you have stationary listener and moving source. Ang tanong, paano natin makakalculate yung frequency na mape-perceive ni moving source given a stationary listener? So we will derive an expression for the frequency of the moving source, for the frequency perceived that by that stationary listener relative to a moving source. Okay, so yun yung pag-uusapan natin. So for example, ganito lang siya essentially. So let's say you have a source initially at rest. And then of course, this source emits sound waves. So ganyan yung tsura niya. So mag-emit yan ng sound wave in that form. And we will assume that this sound wave is three-dimensional kasi yun naman talaga usually yung description natin. Mas madali siyang i-visualize in 3D. And then of course, we know that this stationary, well, it's not actually stationary, it's actually moving with some velocity. And let's say that that velocity is to, in that case, to the right. So gumalaw siya ng konti. So in this case, habang gumagalaw tong particle na to, or tong source na to, this sound wave here also moves kasi may velocity yung sound eh. And in that case, it becomes like this. Okay? So good. I'm just first visualizing this and later I will derive expressions, by the way. So after nyan, syempre gagalaw ulit and after some one wavelength, what will happen is this source here will emit another wave, which is given by red here. Okay? Then, while doing so, gagalaw ulit yan. So, ganyan siya. And, ang mangyayari, mag-emit ulit yan. Lalaki na yung wave na to. Lalaki ito. Kasi, ito na yung wave na yan. So, this is the second wave emitted by the source. This is the first wave emitted by the source. Kasi lumalaki siya. And then after some time, mag-emit ulit yan ang susunod na wave, which is given by this another color here. And in general, this is what happens. So, observe here, tanggalin muna kita, observe here that the difference between these two crests here is much shorter in this direction than the difference in the other direction. Like for dito, mas mahaba ngayon yung difference ito. And that difference is one wavelength. So if this is the observer, kung ito yung observer mo, mas maraming wavelengths ang ma-perceive niya if it's in this direction, if it's moving, if it's towards the direction of the moving source. Diba? Ganun siya, diba? So, compare dito na mas madalang yung mga crests dumaan. Therefore, dito since mas maraming crests yung dumadaan, mas maraming cycles yung nangyayari, mas mataas dapat yung frequency. Hence, you have this Doppler effect. Okay? Gets? Gets yung nangyayari? Questions? Are there any questions, guys? None. So, none. So, I think that's basically how Doppler effect works. You have more frequencies or more cycles moving because of the moving observer. And if we assume that the listener is in the same direction, or in that case, the source is moving towards the listener, mas maraming wavelengths yung ma-perceive ni listener, and therefore, mas mataas yung magiging frequency na makikita niya. Okay, sige. Okay, so ganito lang naman yun. Essentially, what we will be doing in this part of the discussion is to derive an expression for the frequency of the listener when the source is moving towards it. Okay, so yun yung pag-uusapan natin. So let's consider a source first. So meron tayong source, let's say, dot na lang. So it's written by this small dot. And that listener, and that source emits a sound. Okay? Ang source na yan, mag-emit siya ng sound. So, after some time, ang mangyayari sa sound na yan, malaki na siya, syempre. So let me draw it. So, ganyan. So, let me use, I think, a red pen to say na, okay, this is a sound wave. Okay. So, ang mangyayari dyan, ganito siya. It looks something like this. So, syempre, dapat sentro siya dun sa sound. Ganyan. At the same time, at that time, na ganyan nakalaki yung size ng sound wave, let us assume that this source here has moved by some time or at some distance. So after some time, nandito na siya. Let's say nandito na siya. So hindi, balikan ko yung kulay. Gawin kong color blue yan. So this is the new location of the source. And that location, assume natin na nag-emit ulit siya ng bagong sound. Okay, that's another crest, ika nga. So, yan, something like that. Ganyan. So basically, I'm just mimicking what was the on the animation in the previous discussion. So ganito. Okay. Sige, meron na tayong diagram sa ganyan. Ngayon, let us assume first. Let's say, let TS be the time between successive crests. And let US be the sound or the speed of the source. Kaya US. S means source there. So, ibig sabihin, gumalaw itong source na to by some US. Okay? Now, if V is the velocity of sound there, what will happen? Gaano na kalayo yung na-travel ng first sound wave after TS? Gaano na kalayo? Ibig sabihin, gaano na kalayo yung tinravel na tong pulang to? That red circle there. Gaano na kalayo yan? Anyone? Di ba alam natin na yung speed ng sound ay V and it traveled at some time TS. So therefore, how long or how far did the sound wave traveled? So, etong distance na to, ano yung distance na yan? This distance here. This distance here is what? Etong distance na to ay, yes, it's VTS, right? Lakas baka K-pop, VTS. Okay. So VTS is that distance. At the same time, the total distance traveled by the distance traveled by the wave is VS. Okay. And then on the other hand, what about the distance traveled by the source? Gaano kalayo yun? On the other hand, the distance traveled by the source is what? By the source is what? Ano na lang yan? Ito ay V? Tama. Ay, V ba? Tama ba? Wait lang, parehas velocity yung US at saka ano ha? V? Bakit nag-multiply ka ng dalawang speeds? Hindi. Wait lang. Medyo sabaw yun. It's actually, V is the speed of the sound. It's not the speed of the source. Yung tunog travel lang ganon. Therefore, ang speed ngayon yan ay, yes, it's USTS. It's USTS. So this is that speed. Ito yon. This is USTS. Okay? Now, let's assume that the observer or that source is moving towards an observer, which is labeled as X. So ito yung observer. Or in that case, tawagin natin siyang listener. Okay? Then, as I said, ang Doppler effect, sinasabi niya, if you have two successive crests, medyo in-exage ko by the way tong circle na blue na to, pero sa totoo lang dapat walang circle dyan. Kasi yan yung instant na magpo-produce pa lang ng second wave. Pero para lang kita na yung nag-produce ng second wave. Then, ano sabihin na tong length na to? This length here, what's that length? Ano yung length na yan? Kung napansin nyo, remember, nag-produce ng sound yung first source, tapos nag-produce ulit ng pangalawa. Therefore, what's that length there? What's that length? This length here, wait lang. Hindi nyo ata nakikita. This length here. Yan. The distance between the point where the second wave is emitted and the listener, or the second crest is emitted and the listener. Ano yung source na yan? Ano yung distance na yan? Kung napansin nyo, that's equal to what? Yes, that's algebraic equal to what? To that. Tama dun sa nag-DM sa akin. However, ang tinatanong ko, ano yan physically? Kung napansin, di ba, it is the distance between successive crests. Right? Therefore, what's that? Ano lang yan? So parang nag-emit ka ng isa, tapos nag-emit ka ulit ng isa. Ano yung distansya na yon? Ito ay yung, yes, exactly. That's the wavelength of the system or of the wave. This is just lambda. And from there, one can show the wavelength lambda is in turn, so let's say this is lambda f, just to indicate that it's front. is given by lambda. So this lambda front here is related to these two distances here. Diba? Kasi ito lang, masasabi mo na yung sum nitong USTS at saka lambda equal to VTS. And therefore, that lambda is equal to VTS. Lakas talaga maka K-pop nitong VTS na to. Minus US TS, equation 1. Okay? Then this is just equal to V minus US multiplied by TS. Okay? Okay, ito na. Sige, here's the fun part. So, itong TS na to, this is related to the frequency of the source, right? Because we are dealing with the time for two successive crests to occur. The TS, the period, is actually a period, is inverse of the frequency of the source. Diba? So in that case, this TS here is just equal, wait lang. This TS here is just inverse of the frequency of the source. Let's label it as Fs. In that case, we have lambda F, therefore, we have lambda F. This implies that lambda F is just equal to V minus US all over Fs, equation 2. Okay? Ngayon, so what about lambda F? Ito yung wavelength na nape-perceive the listener. Diba? That's the wavelength perceived by the listener. And you can actually think of it as something that's related to the speed of the wave and the frequency perceived by the listener. But the wavelength perceived by the listener is related to the frequency. So in that case, this lambda F here can be written now as V all over FL, where FL there is the frequency observed by the listener. And substituting this, let's say this is equation 3. Substituting equation 3 to equation 2, we see that we have V over FL is equal to V minus US over Fs, equation 4. And ang hinahanap natin ay yung frequency ng listener. Yung frequency na maririnig ni listener. And therefore, solving for FL, we see that. And yung mangyayari dyan, gagawin mo lang, diba? V over FL equals to V minus US over Fs. I multiply both sides with F. So multiply ko by FL to. And then, criss-cross ko sila. Yung ginagawa ko, kini-criss-cross ko lang yan. And it turns out, and then divide both sides by V minus US. We see that FL is equal to V all over V minus US Fs. This is the first equation for Doppler effect. That is, if the velocity or if the source is moving towards the listener, then that is the expression for our Doppler effect. So this is equation 5. Okay? Questions? So, may tanong ba rito? May tanong ba rito? That is the equation for the Doppler effect for this again, approaching, so approaching, or hindi, source approaching listener na lang. Source approaching listener. Okay, questions? May tanong? May tanong ba rito? Anyone? None. Okay. Sir, so wait, sir, paano kapag hindi nag-a-approach yung yung source saan? Paano pag lumala yung source dun sa listener? Ito na. Let's say, what if the source recedes? So, lakihan ko yung recedes. Recedes from the listener. Ang gagawin ko, kopyahin ko lang yung figure kanina kasi pwede mo pa rin gamitin tong figure na to. However, instead of using this diagram or instead of using the right side as the X, ang gagawin ko ay, ayan. So, ang gagawin ko, let's say ito naman yung X ngayon. Ito na si new listener. So burahin ko tong listener na to dito. Okay? So what is now the relationship? Ang tanong ay, nasan yung wavelength? Remember, the wavelength is the distance between two successive crests. Ito na yun. So this is now that wavelength. Diba? So in that case, ngayon, the wavelength and the is now related to the speeds by the following equation. So lambda now is equal to VTS. Wait lang. It's equal to VTS. Sorry for that. Plus US TS, which is actually V plus US quantity TS. But again, our TS is just inverse of the frequency. But TS is equal to 1 over Fs. And therefore, lambda back, B na lang gamitin nating notation for back, is equal to V plus US over Fs. So this is equation 1. This is equation 2. Again, binireset ko yung equations. And this is actually equal to the speed of the wave divided by the frequency of the listener. Kasi yun yung mapaperceive ng listener na nasa likod na. Okay, so therefore, hence, solving for FL, we see that FL now becomes an FL equals V all over V plus US times Fs. Ito yung second equation natin. Okay, that is the source receding from the listener. Okay? Malinaw to. Malinaw tong derivation na to. Malinaw kung bakit ganun yung nangyari sa equations. Are the equations clear? Okay. Malinaw ba? Questions? Questions? Mukhang walang tanong. Sige. So, therefore, for a moving source, stationary listener, our expression now for the Doppler effect looks like this. FL is Fs quantity. V here is the speed of sound in that medium. All over V minus plus US. Yung minus dyan, ibig sabihin ng minus sign dyan, pag lumalapit yung source sa listener. Pag lumalayo yung source sa listener, plus. Okay? Don't be confused with the signs. Ang ibig sabihin lang yan, kapag lumalapit si source, dapat tumataas yung frequency. And therefore, choose the denominator that is less. Na mas liliit yung denominator. Okay? Again, if the source approaches the receiver, the sign is negative. If the source recedes from the receiver, the sign is positive. Okay? Is that clear? Are we clear on this? Malinaw? Malinaw tayo rito? Questions?
Yes, sir.
Okay, I hope that's clear. Sige. So that's the first equation that you need to understand in Doppler effect. Stationary listener, moving source. Again, the signs are in the denominator. Okay.